Hello. So today I'm going to do 8.2 properties of logarithms. There we go. Starts on page 409. We're going to do solve equations using properties of logs, simplify, evaluate expressions. I'm looking for a pen. And the only vocabulary is an equation, which is an equation with logs in it. Couple things before we get started is remember how to rewrite a log. But for equations, so if you're given this, and just like with exponents, if I have 3 to the x equals 3 to the 5, then x equals 5. You just kind of ignore the base. Same with log equations. If you have the same base, so this is base 3, I could cross those out and ignore them, and so x equals 7. So let's do one. I was going to say remember something else. I don't remember what it is. All right, solve log equations using definitions. So we have this, and since there's just one x with the answer, we could rewrite this as an exponent right there. So 5/2 is your exponent. I would put it in the calculator, or if you know, that's the square root of 4 raised to the 5th, which is 2 to the 5th, which is 32. So if you have an x, I'm just going to write log without a base, which is base 10. If you have an x right there, rewrite as an exponent, exponentially. Okay? If you have an x for the exponent, you could just evaluate the log. You had some in your assignments like that last time. And you should never have an x for the base. If you have the x for the base, you could rewrite exponentially too, but I don't remember really assigning something like that. Since log is exponents, you'll never have a base of 0 or 1 because that's 0 to a number or 1 to a number. There's always going to be 0 and 1. So your base, the little number down here, will never be 0 or 1. And also recall, this is what I wanted to tell you, log x with no number in the base is log base 10 of x. That's just understood that these two things are the same thing. And something that will be coming up is log base e of x is actually the natural log of x. It's rewritten like that, which we'll be going over in another lesson. All right, solve log using properties of equality. So here we have one log on each side of the equals. If you were to have this, you would have to move this over and then get log on each side. And then cancel the log, so x equals 3. That's just a separate example. But this one, they're already one on each side of the equals, so we could cross off the log and we get 2x minus 6 equals 4x. Since it's a quadratic, I'm going to move the 4x over, negative 4x minus 6. Since everything is divisible by 2, I will get x squared minus 2x minus 3, so it's easier to factor. Factors to this. What makes this 0 is 3. What makes this 0 negative 1. Since it's log, which deals with exponents, you can't have a 0 or 1 base. You also will never have 0 as an answer. So if I have log base 2, if I multiply 2 to no matter how many times, I'm never going to have, I'm going to put answer here. Your answer will never be 0 and it will never be negative. When I have a positive base, no matter how many times I multiply it, it may be a fraction, but it's never going to be 0 or negative. Okay, so since it's quadratic and since we have some times that it doesn't exist with log, just like exponents, we have that asymptote that it doesn't cross the y, you have to check your answers. And that's what they do on the next page. So we check for extraneous solutions. Now plug in 3, that's 12. This is 9 times 2 is 18. 18 minus 6 is 12. That's PEMDAS. You do not do 2 times 3 and square it. That's too big. You square it and then multiply by 2 and subtract 6. So that's true. They both get 12 inside, so your answer is 3. Now negative 1, you could put it in here. But right here when I put in negative 1, I get log of negative 4. And remember, no matter how many times I multiply 5, I'm never going to get a negative number. So negative 1 is not a solution, it's extraneous, and the only solution is 3. This next check I'm going to do on this left-hand side, but already we have log on the same side, so I'm going to get negative 5x equals negative 2x squared plus 3. Move the 5x, get 0 because it's a quadratic. Now a is negative 2, b is 5, c is 3. Do quadratic formula, so negative 5 plus or minus the square root, square that, minus 4 times a times c, all over 2 times a. To go further, 2 times 4 is 8 times 3 is 24. This becomes a positive. So 25 plus 24, which is negative 5 plus or minus the square root of 49 over negative 4, which is negative 5 plus or minus 7 over negative 4. So first we add, or you could do either one first, but I'm going to add. Negative 5 plus 7 is 2 over negative 4, which is negative 1/2. And then I'm going to subtract. We get negative 12 divided by negative 4, which is positive 3. So those are my two possible answers. You want to go back and check in your original. And so if I put 1/2 in, this becomes a positive, which is fine. If I put 1/2 here, 2 times 1/4 is smaller than 3, so that's a positive. So 1/2 is good. If I put a 3 in here, though, I get negative 15, so 3 is not good. So your only answer is negative 1/2. You're not looking for your answer that could be negative. You're looking to see that the answer here, what is inside the log, should not be negative. All right, now we're going to get into properties of logs, which are similar to properties of exponents. So let's go over properties of exponents to remind ourselves. So if I have a to the x times a to the y, since they have the same base, and I'm multiplying, I add the exponents. Now if I have the same base, I'll put c to the m over c to the n. Dividing, I subtract. Now we're going to have to apply these with logs, and you're going to have to write the log every time, but I'll show you that. And the last one, if I have a to the m raised to the n, we multiply those and we get m times n. So we have these same properties with logs. First, if you multiply, you add log. So there are two things here that I'm multiplying, so I have to make sure I have the word log twice. So this is good when you have something like log of 3x. That breaks up the number. Log of 3 is just a number plus the log of x. Okay, multiply, you add logs. The next one is division. And for division, we're going to subtract logs just like this, but we're going to have to make sure we have log, the word log, for the numerator and for the denominator. So if I have log of 3 divided by x, that is log of 3 minus log of x. And the last one's my favorite because it's an exponent. And think of, you only want them this level. This is down below the bases in the basement. But the exponent should not be there. It goes out in the front and becomes multiplication. So if I have the log of, I'm going to do the square root of x, which is the log of x to the 1/2. That is 1/2 log of x. And we use these properties to simplify problems and solve problems. Okay. This next part is what we used to have to do to estimate the value of logs, but now most calculators have a base that you could enter for logs. So you don't really do it, but I want to go over it to show you how to expand logs. So they're telling us log base 3 of 5 is about this. So we need to estimate this. Since 5 is there, 5 times 81 is 405. 81 is 3 to the 4th. So we have these two become multiplied. We have two things. We have the word log twice. It's a base 3, so we keep the same base. So then we get this, which is 4 log base 3 of 3. And they didn't give you that long of a line to write it because they wanted you just to put 4 there. But this is why. If you have the same base as answer, 3 to what power gives you 3? 1. Log base 8 of 8. 8 to what power gives you 8? 1. Okay? So this is just 1. It cancels to 1. Remember, when things cancel, they're 1, not 0. And then we know this is about 1.465. So you add them, and 5.465 is your final answer. All right, let's do 320. So 320, again, we're using 5 divided by 5 is 10 goes into 320, 32. So 5 is 2 of them. So 64 times 5 is 320. We have a base of 8. I can't write 5 as a base of 8, but 64 is 8 squared. So 5 times 8 squared. So I get the log base 8 of 5 times 8 squared, which is the log base 8 of 5 plus the log base 8 of 8, and it's squared, so I'm going to write the 2 out in front. So my final answer is 2 plus this, and this is 0.7740. So 2.7740. You're not going to have to approximate, but you are going to have to expand and condense logs. Okay, here's one that's division, so they subtracted. We get log base 3 of 3, so that's just 2. This is 1.465. And we get 0.465 to 1,000 would be 535. It goes on doing the similar things with these. So let's go on to the next page. The next page, I just want to expand and condense logs, show you how to do it. That was really quick of it. But if I have, and I want to show you another thing too. So if I have x equals 8e times 1/3. I know you usually don't write them like that. You write 8 times 1/3 times e. But if you, just like taking away the log, you could write in log in front of both. So log x equals, and then expand these. These are 3 things multiplied. Log of 8 plus log of e plus log of 1/3. Okay? Again, division is subtraction, so you could expand it even further. Log of e plus log of 1 minus log of 3. Log of e is typically not written like that. That's ln. Oh, no, it's not. It's not. Sorry. The base is not e. The actual answer is e. So that's not ln. Okay, so that's expanding the log. Here is writing. If you have just x equals 8e times 1/3, then you can write log in front, and then you get this expanded. The other thing is condensing the log, and I have a worksheet from this, but if you have the log base 7 of x plus the log base 7 of y, minus log base 7 of a. So remember, addition is multiply, but subtraction's division. So for 1 log, when you condense, you only write it 1 log x times, this is division, y divided by a. Okay? Or you could put xy in the exponent if you wanted. I mean in the numerator. All right, that's all for 8.2. Your assignment's pretty scattered throughout the problem set, so make sure and go online and find your assignment problems. Let me know if you have any questions.